Hi, everyone. This is David Jasso, and welcome to the multi-cloud, the VMware multi-cloud live stream. Our goal is to really provide demos for cloud ops and DevOps teams, and this is our first broadcast, so I'm happy to be here. My name is David Jasso. I'm part of the VMware multi-cloud team, and my co-host is Lauren. Lauren, go ahead and introduce yourself.
Hi, everyone. Happy to be here. My name is Lauren. I am co-hosting with David, and we'll be sharing these live demos with you and featuring new speakers each week. So I'm excited to be here.
All right. And our guest today is Kenny Coleman of the VMware Tanzu team. Kenny, why don't you tell us a little bit about who you are and also what you're going to be doing with us today.
Well, if I tell you my whole story, might be here for a while, so I'll give you the abridged version. So thank you again for having me on. So my name is Kenny Coleman. I've been in the VMware ecosystem now for quite some time. I used to write a lot of stuff that was just doing vSphere related activities and duties for a long time on my blog, KendrickColeman.com, and ended up speaking at VMworld for my first time back in 2010. And it was a fun journey doing all that and kind of just getting started with just VMware and kind of knowing just the ins and out of vSphere. And then I got to the point where I said, I've kind of learned as much as I want to learn with vSphere, like what's next, like what can I do? And I started getting into application development and learning how to write a little bit of code, get a few things out there. I was never a really great coder. I've never claimed to be. I was consider myself a cowboy coder because I hated writing tests. I just wanted the software to work and run and function. And needless to say, that led me into a team where we were writing some open source software, and this was back at EMC at the time, and we were figuring out a way to do stuff with infrastructure, and how do we combine open source with infrastructure, and why does it matter to EMC? And at some point, they said, go and see what this whole Docker thing is about. And we went off, and should I say, there was a guy on my team that kind of went off and figured it out and saw that, well, we could actually integrate storage into Docker. And that started the whole path. And this was like early Docker days.
Yeah.
And that kind of started the path of figuring out, okay, let's drop everything we're doing and focus on integrating and figuring out how do we bring in storage and open source and all this other kind of stuff. Long story short, it ended up being the catalyst to what became today's CSI driver in Kubernetes. And the team that had been working on that, eventually we all migrated, came over to VMware, and all took on different roles inside of the Tanzu portfolio. So I still have a lot of good touch points with a lot of the engineers that were writing a lot of those drivers, and now they're the ones responsible for building a lot of things we'll be talking today about inside of Tanzu Basic. And I hung up my hat as a developer, knowing that I was never going to be a great one, and went back to doing what I do best, and that's being able to give presentations and really kind of help spoon feed people and say, this is the new light that you should be coming towards. Cool. And so I definitely take I love being able to do that and be able to kind of share that and provide demos of some of the really cool software that people are using, not only just doing that, but we also do a lot of things from bug hunts and trying to figure out usability and user experiences. Also building other kind of collateral that we can share internally as well as externally.
Very cool. And you're going to then, why don't you talk a little bit about what you're going to show today in the demo?
Yeah, so today we're going to be looking at Tanzu Basic. So Tanzu comes in a few different, should I say that the whole idea of Tanzu, if anybody doesn't even know, it's actually Swahili for branch. That's where the name comes from. And the idea behind it is to look at how do we branch out from what we've been doing in just virtualization into this next realm, and really containerization, not only just containers, but Kubernetes. There's other ways of modern application deployment, and that's really where a lot of this starts coming in. And we look at a few different products and projects that have all been taken into the Tanzu portfolio, and a lot of this is built off of open source software. So what we want to be able to do is we want to take some of these projects, and every single one is great on their own, but when they're put together, they really make a solution. And so the idea was, how do we take some of these disparate products and projects and but put them together into something that is more holistic and more complete. And so that's really where the Tanzu additions came in. And so Tanzu Basic is exactly what it sounds like. It is the most basic form of what we can get to actually have a production-ready Kubernetes cluster. So what we're going to do is we're going to look at a few different things. I'll just kind of set some context with some slides so you kind of understand exactly like what products and what projects are in here that are compared to standard versus advanced. And we'll kind of give you an overview of a little bit at a high level what they are, and then we'll show a demo of how they all kind of work in unison, just to kind of paint a picture for you as well.
Okay, excellent.
Sounds good.
Excited.
Easy enough? Cool. Well, I'll go ahead and I'll get rocking and rolling here. So no need to do another introduction, but let's go ahead and get into it. So the idea behind Tanzu Basic is that it really is our fast path to Kubernetes. We want to figure out a way that we simplify operations. And that just means that we want to make this uniform across whatever types of environments that you are deploying it to. Tanzu Basic is only entitled to vSphere. So if you are running vSphere on your premise, or if you're running vCloud Foundation, this is where we're going to see where this is entitled to. We also want to enable self-service. And this is because we have been in the situation before where we want to provide either our DevOps teams, our developer teams, or whoever access to infrastructure. And so we've seen this playbook done time and time again with infrastructure as a service. And we are now seeing this again where people are asking for containers or infrastructure to run containers, or just give me a Kubernetes environment. And so we want to enable that and allow people to have self-service access to that as well. And as I mentioned before, everything that we do is aligned to open source. Not only are we just kind of talking the talk, but we are walking the walk as well. Everything that we inherit or we build off of is something that we are actively contributing to, or we are active maintainers in those projects. And so we want to make sure that we are putting out really good open source projects, but we are wrapping them with better usability as well as support in a lot of these additions as well. So when I talk about some of the paradigm and the kind of way that we are separating out the roles between them, we want to kind of figure out, like, where do you live in here? And as a former vSphere admin myself, I look at this and say, well, I don't want to give up the infrastructure. I still want to make sure that I maintain everything that I need to be able to perform my duties and not let the infrastructure just kind of go haywire. So I've got to make sure that everything is there that I can deliver high availability. I can deliver the ability to make sure that, you know, DRS and HA and all that stuff is there still working in unison. But I also want to make sure that if I have different business units, I've got different applications, I've got different SLAs for all these things, I can create a multi-tenant type of environment where I can allow developers to, or whomever, to consume resources from any one of these types of these facets, if you will. And at the end of the day, I want to make sure that I have control over the infrastructure. So I don't want to just give everything over and say, you know, go run with it, but instead I still have to control it. I still have to maintain it. We still have governance models that are in place. As a DevOps persona, or as an operator, or as a developer, whomever it is, you need access to infrastructure, and this is what you need. And this is one of the things that we've always fought forever: is how do we keep you from always just going to AWS and swiping a credit card and keep going? We need to make this a lot easier for anything that's on premise to be consumed by people that are asking for it. And so we want to enable that, and we do that through, you'll see in a demo here in a little bit, but we do leverage Kubernetes as the larger ecosystem. So anything that we are doing is somehow tied back into Kubernetes and stuff that we are contributing back to as well. You also get access to the newest Kubernetes releases. Now, it's not going to be bleeding edge. It's not going to be the latest and greatest that comes out. However, it is going to be a patch version that we have gone through, and we have put in all of the guardrails and all the, you know, everything that we know what makes a coherent Kubernetes release, and we supply that as something that we can give support on as well. And as an operator, I don't care about what the underlying infrastructure is. Everything is abstracted. That was the great thing that virtualization created for us, and it's the thing that containerization is creating as well, because we are slipstreaming in all of the vSphere cloud provider interfaces, everything that vSphere needs to be able to talk to storage. All that is already built into the Kubernetes release, so you don't even have to think about it. And so when we start looking at the additions, this is kind of how we have this sort of like sliding scale of what's here. So in the Tanzu Basic portfolio, what we'll be talking about today is pretty much everything that you need to create a production-ready cluster. So we'll look at getting everything ready for Kubernetes, making sure that we have container networking, we have a load balancer, so we have north-south traffic in and out of the cluster, as well as we have a container registry of where to store all these. And then as we move up, you get a little bit more feature richness, and we talk about ingress, we talk about the ability to have a global view of all of your clusters. We have policy management, backup, and restoration that's built into there as well. And you have access to more types of infrastructure too. So not just on vSphere, but as well as on AWS and Azure and everything like that. And this might be, I think, for anybody that's on the technical side, like, okay, show me the money, like show me what I get with this. And this is what you get with Tanzu Basic. So we'll talk a little bit about Harbor. We'll look at NSX Advanced Load Balancer, which was known as Avi at one point. You have Antria, which comes out of the box as your container networking interface. This is just something that's default. Calico is there, but Antria is your default. You also have VMware Tanzu Kubernetes Grid. We'll talk about that here a little bit, so you kind of see the two sides of it. But to understand that you get access to either one that you choose when you get Tanzu Basic here. You also have access to FluentBit, which is part of our extensions framework. I'm not going to really talk about it here, but just kind of know that we do have a whole extensions framework that's built on top of VMware Tanzu Kubernetes Grid, meaning that it's a simple way to deploy other types of open source applications. So you can see as we kind of go across here, you have things such as Prometheus and Grafana and external DNS that we have other open source extensions for, but with Tanzu Basic, you have the ability to run FluentBit and have support on it as well. And so we'll kind of talk about a little bit all these. So as I'd mentioned with TKG, and you'll hear me kind of throw that around. So Tanzu Kubernetes Grid is a way that we can deploy Tanzu Kubernetes clusters consistently across any type of environment. But for Tanzu Basic, it's just running it consistently on top of vSphere. And you know that you're going to get the same exact type of cluster every single time you want to do it. The great thing is if you've never done this before and you're just now getting to Kubernetes and you go try to spin up Kubernetes on your own, you're going to find it's very, very difficult. However, what we've done is we've built all of this on top of Cluster API, which is, again, a big open source project that VMware is an active maintainer to and contributor to. And this is how we automate the ability to continually create Kubernetes clusters. And that Cluster API component is has different drivers for a multitude of different infrastructure providers out there. So we maintain a lot of those too as well. We also have integrated services. That's kind of talk the extensions framework that I was going along with. And of course, align with open source because it is built on top of Cluster API. So when I talk about Tanzu Kubernetes Grid, it is your enterprise Kubernetes runtime. We are utilizing Cluster API to enable the cluster lifecycle management, but it really comes in two forms today. And you have Tanzu Kubernetes Grid, that's sort of this CLI binary-based aspect of it. And then you also have this baked into vSphere of Tanzu, which we call Tanzu Kubernetes Grid Service. It's the same exact thing, same exact outcome. It's the ability to programmatically and declaratively say, I want to have a Kubernetes cluster that looks like this. And both of them run on top of vSphere. They're just both instantiated in different ways. And today we're going to be looking at about how to do this with vSphere of Tanzu, which will come with vSphere 7. You might have also heard this called Project Pacific at one point. So if you're familiar with that, that's kind of what we'll be looking at today. And as I'd mentioned, it is a solution that can run on top of any infrastructure. It doesn't really change except a few configuration variables, but the ability to say, I want to kubectl apply and create a cluster, it's going to go and deploy it on any type of infrastructure. But with Tanzu Basic, you're only entitled to be able to run this on premises with vSphere environments. And with inside of Tanzu Basic as well, you have a few different things inside of networking. As I mentioned, you have the CNI or Container Network Interface, which is Calico as well as Antria. Antria is going to be your default. With layer 4, we have NSX Advanced Load Balancer, or what was known as AVI, and that's going to take care of your north-south traffic. And I'll show you an example of that, of just spinning up a simple NSX endpoint, or sorry, Nginx endpoint, and making sure that we have an IP address that's given to us of how we can access our applications that are running inside of Kubernetes. You also hear this idea of layer 7, ingress load balancers. That's not included in basic, but if you step up to standard, you get things such as Contour, which is another open source project that we wrap support around. And really layer 7 is just your ability to not burn up a ton of IP addresses, but really route based on the application. So Harbor is one of these premier projects that are inside of the Cloud Native Computing Foundation. It is a graduated project, meaning that it is at the same exact level as Kubernetes. And this was something that came as a project from VMware China's R&D. And it started back in, I think, 2014, 2015 timeframe. But it is now one of the premier projects and probably one of the most notable container registries that you can run on-premise today. It is super feature rich, and I won't be able to show you everything, and you can kind of see on the right-hand side about everything that goes into it, but just kind of know that we do have the ability to do a lot of different things, but I'll kind of show you a quick demo of that as well. So let's go ahead and we'll dive into it here real quick.
Great overview. Thanks so much.
Yeah,
Tony.
well, we'll save that look more or see more slide a little bit later here. Let me see if I can zoom in just a little bit for you, because I know it's kind of maybe a little hard to read. A little bit better. All right. So this is your vSphere with Tanzu environment. I'll act like you don't see these namespaces. I'm going to go ahead and kind of just clear that up to see if act like nothing happened there. So when you are getting ready to start your Kubernetes journey, one of the great things about this is that you don't want to figure out like, how do we integrate, vSphere and Kubernetes and put all this together, but instead it's already here for you. This is done through a new tab we call Workload Management. You might hear the word WCP, or what we call Workload Control Plane before, but what this is your integrated Kubernetes environment. Now, since I've already done the setup, you're not going to see any kind of setup with inside of here. But what the whole setup process was basically coming through here first of getting AVI up and running, making sure that it's connected to vCenter. Once I do that, I give it some IP addresses and I say, hey, this is the subnet that you can use for the primary management network. These are the IP addresses you can use for the workload network. And the workload network is where our Kubernetes clusters are going to go. So once I set all that up, pretty great, done, nice and easy to go. And this is where I can see inside my cluster view and say that I have this particular cluster right here has been enabled for WCP or workload control plane. Now, once I did that, that spun up these supervisor cluster control plane virtual machines. These are in cluster API world what we call the management cluster. We call them here, we call supervisor cluster. The supervisor cluster or the management cluster, when you provision anything with Tanzu Kubernetes Grid, these three control planes are nothing more than a Kubernetes control plane. But we put in what are called custom resource definitions with them. These custom resource definitions know how to talk to the infrastructure. And they are also the ones that are responsible for keeping a heartbeat, as well as knowing how do I declaratively make sure that what I am provisioning looks like what you're requesting. So if I was to say, Lauren, I need a cluster that has one control plane node and 5 workers. What I would do is I would give that to you, say you're my supervisor control plane, and you would go and create it. That's the same exact thing that I'm doing here. I'm saying to the control plane, this is what I want my cluster to look like. Go ahead and go create it. So that is what it's doing. It's also keeping a quorum of it. So if anything changes or if it's losing a member, it's going to go ahead and try to rectify that and always try to get to that declarative model. So that's how Kubernetes works, is off of, of course, that declaration model. All right. So once that's up and running, the next thing I have to do is create what's called a namespace. Now, a namespace is, you might be thinking, kind of analogous to a a Linux namespace, but it really is. It's a delineation of how do we break apart anything that we want to run, the clusters, whether they are the applications or the business units, or each developer has one. It doesn't really matter. It's up to you to figure out how you want it. But the namespaces, it's nothing more than just giving a name. But once you give it a name, I can come in here and I can do a few things. So the cool thing is that this is all baked into role-based access control of vSphere. So when I want to add a new permission, I can just go ahead, select my Active Directory domain name. I say whatever user it is, and then I can put them as edit, read, write, edit, read only, whatever it is. Since I already have my self in here, then I don't need to worry about it. Now, the other thing is that I have to add storage policies. So this is pretty simple. I go to my data stores with inside of vCenter. I apply some policy to them, and I apply the policy here. Now, once I do that, you'll kind of see how this all sort of flowing when I need to create a cluster. So keep in mind this Kubernetes storage policy right here, and you'll kind of see this pop up in a little bit. I also have the ability to kind of look at any of the what's being provisioned or capacity and usage, but I can also set limits. This is pretty powerful because if I don't want anybody saying, oh, I'll just go ahead and run off and take up 62 terabytes of storage. No, I can go ahead and I can say only take up 10 gigs, or I can say you only have this many resources to be able to consume. That is where the control of the governance comes in as a vSphere admin to make sure that nobody's just taking control of the environment and going crazy with it. From here, I can see that I have one TKG cluster up and running, but I also have something brand new which came in the latest update, which is called the VM service. The VM service has the ability to create your own virtual machine classes as well as limit the type of classes that are there. So when I go to the virtual machine service, I can see the types of classes that are available to me. Go ahead and scroll that down. So I can see at the very, very bottom here, I've got best effort, extra small, guaranteed extra small. I've got my own what's called Tanzu team here, guaranteed medium. You can see that they've got a bunch of different types of variations to them, what we call t-shirt sizes. But we can see the very large end here, guaranteed 8XL, 32 vCPUs, 128 gigs of RAM. If I was to give anybody access to this and they're like, oh, of course, I want all my virtual machines to look like that, it would go pretty crazy pretty quickly. But I have the ability to create my own VM class. I can call it whatever I want. Also, I should mention that you see the words guaranteed versus best effort. If you've been in the vSphere world for a while, you understand that guaranteed is we're putting a reservation on the resources on the CPU and RAM versus best effort, which is kind of just pretty generic. It's default. We just throw it in the cluster and we let DRS and let it all figure out on its own. But I can create my own VM class. I can call it whatever I want. When I go to this namespace, I can also limit the types of virtual machines that are accessible to this particular namespace as well. So in this instance, I only want best effort, extra small, small, and medium available to whoever is going to consume from this resource. All right, so once I have that set up, now I can say, hand it over, whoever can have access to it. So what you would do is you would actually come over here and go to this particular link or give them access to this link. And what this is going to do is going to open up the ability for them to download the kubectl binary and the vSphere integration plugin that we have created. I've already kind of done that here myself here. They're actually running here with inside of here. So kubectl vSphere. Now, once I do that, I have to authenticate to my environment. Now, I've already put in a few different environment variables here for my supervisor cluster IP. My supervisor cluster IP, just to give you an idea of what this looks like, is when I go to here, is it's going to have a few different IP addresses available to me. We can see that this one has 5, you'll see this one has 4, and this one has 4. But that 5th one is the important one, and that's the one where it actually starts. So it's going to start at 10.202.120.25 for my particular environment. And so you could take that, you could go put that inside of your DNS, and you could have DNS access to it if you want. But once I do that, I log in with the username administrator, and I don't care about TLS certificates. So let's go ahead and kind of get to work here. But we can see this is what I have access to me. So I have 2 different of the namespaces, which is Tanzu 01 and shared services. I've actually already gone in here and I've deployed a Harbor instance in the shared service because I want everybody to have access to it, but only a few people to have access to the namespace. So I have a Harbor cluster already running with Harbor. But once I do that, let's go to the actual namespace for it, for the Tanzu namespace. And when I do that, I can get a little bit of a clearer vision of what's running in here. So I can say kubectl get TKCs. What are my Tanzu Kubernetes clusters that are running? I can see that I've got cluster 01 up in here. Well, let's get a little bit more information on it. Describe TKC cluster 01. And I can see a little bit more information. I can see exactly what the virtual machine status is. We can see that they're best effort, extra small. There's 2 count. And here it is, that storage class, what I was talking about earlier. He said, this is where we want to provision it. Now, if this was my first time doing it, what I do is I create a manifest. This is a simple Kubernetes manifest. And this is what this is all it takes to be able to create this Kubernetes cluster. I say that this is the name of the cluster. This is the namespace that I wanted to deploy it to. This is the version of Kubernetes that I want to run. I'll show you that here in a second too, about how do I know which version of Kubernetes. Here's the control plane, here's the worker count, and again, the class as well as the storage class about where this should run. Now I set the default storage class because once this is provisioned, I need to have a default storage class because that's what I prefer for creating Helm charts or anything like that that relies on a default storage class already being provisioned for that Kubernetes cluster. Now, as I mentioned, this particular version here, how do I know which versions are available to me? Well, I would say kubectl get what's called TKRs or Tanzu Kubernetes releases. Now, my screen's not wide enough to be able to show you. It's a little bit kind of jumbled here, but we can see that like down here, we've got a few different versions. So we've got 1.19.7, we got to 120.2, 118.15. Now, the other cool thing about this is that I also can see on the right-hand side what updates are available to me. So if I'm running, say, 1.18.15, and I want to upgrade to another version, it can show me right here exactly which versions I can actually upgrade to. So I can upgrade to 119.17. I cannot upgrade to, say, 1.20. Kubernetes knows you have to go in a sequential fashion. So if you want to go to 1.20, you got to go to 1.19 first, then you have to go to 1.20. Now to kind of give you an idea as well as what does this look like inside of vSphere, well, here we go, Tanzu 01, cluster 01, it's up and running. All right, well, let's say I want to, let's edit this a little bit. Let's say we want 3 workers. So I say kubectl edit TKC my cluster 01 here. And this is, I'm running the actual running configuration here. If I wanted to edit the actual version of Kubernetes that's running, I can do that right here. All I can do is I would set this full version to null, and then I would set this version to whatever it is. So if it was the next version up, 120 dot whatever, I would go ahead and set it there. But you can see I'm already running the latest because it is 120. Coming down here, I can see that here is my worker count, and I am going to change that to 3. Now, when I quit this, we can see that it's going ahead, it's edited, come over here, give it just a few seconds, and we will see that it will, there we go. So the next one has already kind of started being added to the cluster. This process will take probably about 10 minutes for it to be added back into the cluster. But again, just to kind of show you how easy it is to start adding and scaling out these particular workers when you do need them. All right, so now that we have just from a cluster level ready to go, well, how do we get into the cluster, or what do we do? Well, let's go ahead and same thing, kubectl login, and we have to vSphere login into the cluster. All I'm doing is setting the Tanzu Kubernetes cluster namespace, which is Tanzu 01, and setting the cluster as 01 and logging in. Once I do that, it's going to add it to my kube config, and I'm going to say, you know, use this context. Use context of cluster 01. And once it's there, I interface it with it just like I would any Kubernetes cluster. Git pods -a, and we can see here all the pods that are running within inside of this particular cluster. So exactly what you would expect. Everything is upstream. So everything that you would think should run in a Kubernetes cluster will run in a Tanzu Kubernetes cluster, because this is nothing more than an upstream type of way to be able to do this. Now, one thing that is kind of different is that we do have security built into this natively, meaning that we have pod security privileges enabled for every Tanzu Kubernetes cluster that comes with vSphere Tanzu. I know PSP is actually going to be deprecated here soon, but for now, we still have it available to us. Oops, let me bring this. So the way to be able to kind of like negate this to make sure that we can actually deploy something is we want to make sure that anything with the VMware system privileged has this particular role binding, so we can then go and provision our images, our deployments, or whatever it is. So before we create a deployment, I kind of want to go show you what's happening over in Harbor. So again, Harbor is this open source container registry product, and it's super, super feature rich. And I've already gone through and I've provisioned a few different images to here that actually came from my own laptop. So before we get into it a little bit, I'll just kind of show you that I created this Tanzu project. With inside of the Tanzu project, I have two different images. I've got Redis and Nginx. Let me give you, that's maybe too much there. So you can go here, and I got Nginx. Now, the cool thing about this is that there is native critical vulnerability scanning that happens with inside of here. So this was the an image that I just pulled. It was like, I don't know, it might have been Nginx something, but I called it Nginx stable. I just went ahead and just put it up here. I can go into the artifact. I can get a little bit more information about it. And this was coming straight from Docker Hub. So nothing that was crazy. I didn't mess with anything. It was just straight from Docker Hub. But we can see that it had it ran a vulnerability scan from a high level over here. We can see that it is a level of critical. As an administrator, I can set policies that says do not allow anybody to be able to pull an image that is at a level of critical or anything like that. I can also say if these are some of these vulnerabilities are things that are just, you know, they're not really that critical, I can set whitelists for all of these. So these can then pass tests to be able to make sure that that doesn't happen. I can get a high level overview of really what the issues are or anything like that. But this would be on me as an application developer and an application owner to make sure that I go and either fix some critical vulnerabilities, I patch my images, and then I re-upload them and I get them rescanned. So I can see in here that these are the critical vulnerabilities. I can go and click on it. When I do it, it takes me to the critical vulnerability. I could read more about it. I could go way deep on it, but again, we don't need to go that far. But just to kind of just show you, I've got this this Tanzu project. I got Nginx image up in here. We'll show you how to do that. The other kind of cool thing is that we have there's replication that's built into this. So if you want to have images that are replicated to all your data centers across the globe, you could do that. You can have kind of like one main source of truth. You could also have replications that actually pull from images, meaning that, just to kind of give you an idea of what I did here, I have a replication that's set up because I am using, let me just find a registry here. I just set up Docker Hub, just straight Docker Hub. And I said, I want to pull the latest Nginx image every single night from Docker Hub. And so I created this replication rule right here. And what that's going to do is it's going to pull the latest image and it is going to put it into the library folder here, which is your main, you know, say Docker pull Nginx, you would say whatever pull here. And this is what it's going to pull. You can see that it's had 8 pulls. This is a different SHA than what we had before as well. We can come in here, there's different artifacts, different vulnerabilities, different everything in here. So we can see that they are different images. All right, the last thing I'll talk to you about with Harbor as well is that it has a proxy cache feature. If anybody that's unaware of what happened with Docker Hub in the past year is that you try to pull images and you're probably going to get hit with a rate limit error. And this is because they introduced rate limiting to make sure that people just aren't having anonymous pulls. And so you either have to register your name and be able to do a few more pulls, or you have to start paying Docker to do a lot of pulls. If you were doing this behind a gated firewall or anything with inside of your organization, here at VMware, we can't pull nearly anything from Docker Hub because there's 35,000 other people that are trying to pull things from Docker Hub, all from, you know, a couple different IPs. So therefore, it's very, very hard to do that. And I'm sure a lot of people are starting to hit this proxy limit error because you'll try to deploy something and everything's sitting at a stalled image at this point because it's not being able to pull. But what you can do is you can set up a proxy cache. I call it just Docker cache here. And what you would do is you would say Docker pull, or you would have a Kubernetes deployment that's going to pull something, and you would say from this particular IP address, and we would say Docker cache, and then whatever. If it doesn't find it here, this is going to pull it from Docker Hub. In my instance, it's going to pull it from Docker Hub and keep it here. So anybody else that wants to access it will now just pull this particular image. So saving you a bunch of internet resources and pulling stuff offline. All right, I've talked enough about this. Just know that Harbor is awesome. Use it. And I didn't even get into things like quotas and garbage collection, online garbage collection, all that sort of stuff. So
that's cool. It's great to see how far it's come since when that project was launched. Well, 5 years ago, 6 years ago.
Oh yeah, it's heavy duty now. Okay, so let's go over here, and I want to create a new deployment. So just to give you an idea what this looks like, so I'm going to create a new deployment. This is going to be pulling from this particular image right here. Sorry, this my Harbor image here, and the Tanzu Nginx stable image. Right. Go ahead and do that. We can see that's created. kubectl git pods. We'll probably see that it's still being created here. Oh, it's already running. That was pretty quick. If we go kubectl git deployments, we can see that there's my Nginx. We'll say describe deployment. Everything should probably be nice and because I can't spell deployment correctly, but we'll get the pods. It's a little bit better to run here. Describe pod my Nginx here. We can see it's up and running, successfully created. It pulled, no issues. So great. Everything's going great there. Let's go ahead and scale it up. So instead of me trying to type it out and fat finger it again, I'll just go ahead and copy and paste it over. And now I'm scaling up to 4 different replicas that are going to be spread across 3 of those workers. So we can kind of get pods now, and we can see that it's running across all of them. I could go to do a describe on them. I can see exactly which node it's running on, but you kind of get the idea. Now, how do I access it? I think that's one of the things that we don't understand here in Kubernetes land. If you're just getting started, is how do I access this application now? Well, there is the idea of services. And right now we can see that really there's no way to access anything inside this cluster. But what we've done is we have integrated this in with AVI, or NSX Advanced Load Balancer. And this gives us the ability to have a layer 4 north-southbound traffic from here. So what I'm going to do is I'm going to say, and this is the kind of the cheating way to do it. If I was doing this the right way, I would create some sort of Kubernetes manifest and apply it. That would have a much better way to look at it. But just for CLI purposes here, I want to expose my deployment of Nginx here on port 80, because of course that's what I'm going to access. And I'm going to have a type of load balancer. This type of load balancer is going to know to talk to Kubernetes, which is going to know to talk to our integration with our cloud provider interface, which is going to know to talk to WCP, which is going to know to talk to AVI to then create a load balancer and tie it all together here. So just to give you an idea, before I do that, I'll show you what's happening inside of AVI. So I'm going to come inside of here. And we can see that we've got a few virtual services that are running. Let me just kind of get a longer depth here. And this kind of just goes to show the different kinds of pools or sorry, the different types of services that are running. Again, let me blow this up so you can see a little bit more. So we have our shared services cluster. And this is also kind of just show you as well, as every time you create a Kubernetes cluster, you are going to get a load balancer or a virtual IP address. And this is because this is going to be your interface to the Kubernetes API. And we do this for one big reason, and that's to be able to take care of rolling upgrades. So whether you have 1 control plane node or 3 control plane nodes, you're going to have a load balancer for it. And when you do a rolling upgrade, the idea is it's rolling. We never upgrade Kubernetes on the virtual machine itself. Instead, what we'll do is we deploy a new virtual machine with an upgraded Kubernetes version into the cluster, and then we will we'll demote and remove that old Kubernetes version from the cluster. So you'll have this rolling upgrade fashion. That's sort of how everything works. And so this virtual IP address will make sure that it never changes. And so you're always accessing the same exact IP address for your Kubernetes cluster. So we have that. I also have one set up here for Harvard of accessing it through here because see .46, .46, and that's how I access there for north-southbound traffic getting out of Harvard. All right, so let's go ahead and let's deploy this here. So once we do this, it's going to take probably a few seconds here, but I would say, and then I want to say get my services, and we can see that it's already being pulled from Avi here, but let's go ahead and just do a little bit of refresh here. And we can see that there it is. So there's 24, or there's .48 that got provisioned for us. We can see from here that this is being tied to this external IP address is being tied to port 80, which is going to my Nginx deployment, which will be rolling through all 4 of the different replicas that are available within inside of this environment. Coming back over here to here, what do you think is going to happen? Exactly, right? We can access Nginx now. We have our layer for north-southbound traffic coming into here. So
cool.
With that kind of
nice.
gives you, kind of gives you an overview of what it's like to just start from building your first Kubernetes cluster, getting kind of know the governance model as a vSphere admin, as a operator or consumer of it, knowing how to have container image management control, making sure that you can pull from there, everything like that. It's all built into this nice little package here. And of course, I didn't go into some other components and pieces of it, but at a very high level, you get an idea of the simplification of where it is, of where we just started almost from nothing and got Kubernetes on our first application up and running.
So VI admins that are ready, that have access to this capability, how hard is it to get going? Is it super difficult or pretty straightforward?
Yeah, so not with Tanzu Basic. It's actually very, very simple. So you'll see that WCP right here, this workload management. Once you have vSphere 7 installed, you go through there. You can sign up for a temporary license, and you go through, and it'll just kind of have everything through there. But Tanzu Basic is really your entry level into getting into here. It's actually a very low cost add-on to vSphere. Most people are wondering, oh, what kind of license do I need? You have to have Enterprise Plus licensing already to be able to use this, because we utilize a virtual distributed switch and some other components that are reliant upon Enterprise Plus licensing. So that's your first aspect to this. But Tanzu Basic is a very, very low cost way of getting into this. And I'm not a salesperson, so I can't give you the numbers, but it is much lower cost than you'd probably anticipate.
And it gives VI admins an entry point to start offering a Kubernetes infrastructure to their development teams, right?
For sure, yeah.
It's been great. This is an awesome introduction to it. Thank you so much, Kenny. Did you want to cover anything else, or is that pretty much cover everything?
Glad you said something. Thanks for setting me up there right at the end. Yes, I'll just blow this up here without going into full presentation mode. But if you do want to learn more, there's a lot of great resources out there. So modernapps.ninja, we have integrations into the hands-on labs there as well. So you can kind of get an idea from everything from containers 101 all the way to Tanzu standard and advanced and 301 level knowledge. So there's a lot of stuff in there of how to kind of just get hands-on with it, as well as learn more things. Cube.academy is a free resource that's coming from VMware, but it is not VMware specific at all. It is just how to learn more of the inner components of Kubernetes. We just showed you the deployments and services today, which are by and large a very big portion of it, but there's things such as operators, daemon sets, and I mean, we can just keep going on of all the different types of Kubernetes artifacts that there are, but you can learn a lot more there. Again, hands-on labs, there's a bunch of YouTube videos out there, so make sure you go check that out, quick start guides, and of course you can find more on our blogs, on the Tanzu blog, as well as the core VMware blog as well.
Yep, and I know Kube Academy, I know they added a specific set of content now that's specific to VI admins that are sort of moving in that direction of being a Kubernetes admin as well. So I think there's some great stuff out there. This has been awesome. It's been great to have you, Kenny. It's been a great first show with, an inauguration for this show. So thanks so much. Going forward, as Lauren said, we'll be here every week. We expect to be here. And I did want to point out to anybody that's watching, and if you watch this live, or if you watched on replay, we'll be replaying the show on demand. And if you like the content, please subscribe to the channel. We'd love to have you be part of it. So with that, I'd just like to say thank you, Kenny, for being on today. Lauren, any last words, and then we'll jump off.
No, thank you so much. Yeah, I appreciate it. And thanks for sharing these links as well. I think these are helpful. And yeah, as David said, recording will be available, and we'll be excited to share new content every week. So please subscribe and check it out.
All right. Thanks, everyone. Talk to you soon.
Thanks, Kenny.